Alrighty, so looking here at our verification problems, our proofs, I'm going to start with number 5 here, which is 1 minus the cosine of a, or alpha, over sine of a is equal to sine of a over 1 plus the cosine of a. And when we look at what we want to first do here, there's nothing we can really get rid of right off the bat looking at the terms we were given in our identities. So I'm going to cross multiply again, like we did in a previous problem. And this is going to give me sine squared a is equal to 1 minus cosine a times 1 plus cosine a. Now that I've done that, like I did in the previous problem, I want to distribute. So 1 times 1 is 1. 1 times cosine a, 1 times negative cosine a, is minus cosine a, and then our 2 cosines will give us negative cosine squared a. We can cancel those 2 terms, copy everything down, and we can immediately see that what we have here on our right side is going to be our Pythagorean identity. If we were to subtract over a cosine value, if we were to subtract over our cosine value, we'd have 1 minus cosine squared theta, and on the left we'd have our sine squared theta value. So that's what we're going to sub in. And as it turns out, that value matches the left side of our equation, and that problem is solved. So we can move on to number 6 here. Looking at problem number 6, the thing that immediately draws my attention is this squared term in parentheses over here, so I'm going to start working with that. Copy down our left side. I'm going to write out the term. Make sure you can see a little bit, sorry about that. And I'm going to distribute. So first I'll bring down the left side of our equation, but then I'm going to look sine squared times sine squared, or sorry, sine theta times sine theta is sine squared theta. Then we're going to have our inner and our outer terms are both going to come to sine theta cosine theta, so that'll be 2 sine theta cosine theta, and then our 2 cosine values will give us cosine squared theta. Looking at what we can simplify here, we see that this term right here, our 2 sine theta cosine theta, is one that matches our sine double angle identity. We see 2 sine theta cosine theta right there, and we also see that the leftover terms of sine squared theta and cosine squared theta match our Pythagorean identity, and those 2 terms will give us 1. So copying everything down on our left, 1 plus sine 2 theta. These 2 terms, like we just said, our sine squared theta and our cosine squared theta will combine in our Pythagorean identity to give us 1. And then we said that this term, 2 sine theta cosine theta, is our sine double angle identity. And with that, our 2 sides match. Alrighty, moving right along here. Question 7, we have 1 plus sine x over 1 minus sine x minus 1 minus sine x over 1 plus sine x is equal to 4 tangent x over cosine x. So this is a longer problem, and it looks intimidating, but it's totally manageable as long as we stick to just taking it piece by piece and, you know, just managing what we know we can work with. So the first thing I want to do, because we can't really get rid of any of these individual terms on the left here, and that's our more complicated side, so that's the side I want to start working with. We can't really get rid of any individual terms, so what I want to do is get common denominator so I can take care of that subtraction sign. So I'm going to multiply our left here by 1 plus sine x over 1 plus sine x, because that's what's missing from our denominator. And for our right term, we're missing 1 minus, oh, there should be a minus line there. Oh, sorry. There should be we're missing a 1 minus from our term, or our denominators. So multiply by 1 minus sine x over 1 minus sine x, and that's all going to still equal 4 tan x over cosine x. Okay, so when we multiply these values out, when we distribute the numerators over here, so we have 1 plus sine x times 1 plus sine x, we do 1 times 1 will give us 1, 1 plus sine x will give us sine x, and then this inner 1 and this inner sine x will give us a sine x, so we'll end up with 2 sine x's, and then our 2 sine x's will give us sine squared x. Our denominator will be 1 plus sine x times 1 minus sine x. And for our second subtraction term, we're dealing with, on the numerator, 1 minus sine x times 1 minus sine x. So when we distribute out those terms, we have 1 times 1 is 1. 1 times negative sine x is negative sine x. Our inner terms, our negative sine x and 1 will also give us a negative sine x. So that's going to be negative 2 sine x or minus 2 sine x. And then our negative sine x and negative sine x will give us positive sine squared x. And our denominator will be the same. 1 plus sine x times 1 minus sine x. Still equal to 4 tan x over cosine x. Alrighty, so now we can subtract these two terms. Remember, when you're subtracting more than one term with the same subtraction time, sign, oh my goodness, you have to distribute that negative throughout. So I'll copy down we have on our left side here, which is 1 plus 2 sine x plus sine squared x. And then, like I said, you have to distribute this negative. So you're doing not just one, you're not just subtracting this term, you're subtracting each of these individual terms. So you do minus 1, then you do minus a negative 2 sine x. I'm going to put this whole thing in parentheses just so it's that much clearer. You're doing a 1 minus, or sorry, you subtracted your 1, so you got your negative there. You're subtracting a negative 2 sine x, so that double negative will become a positive 2 sine x, and you're subtracting a positive sine squared x, so that will remain a subtraction sign. For your denominator, I'm going to distribute this out now. You have 1 times 1 over here. We'll give you 1. You have 1 times sine x, negative sine x, and then another 1 times positive sine x, and then a negative sine x times a positive sine x. And this is all still equal to 4 tan x over cosine x. Okay. So now looking back to our numerator, we can start to cancel out terms. We have a positive 1 and a negative 1 here. Those two will cancel. We have a positive sine squared x and a negative sine squared x. Those two will cancel. Down here in our denominator, we have a negative sine x and a positive sine x, and those two will cancel. So when we copy everything down, we have a positive 2 sine x and a positive 2 sine x. Those will combine to give us 4 sine x. In our denominator, we will have a 1 minus sine squared x, still equal to 4 tan x over cosine x. Alrighty, so there's still one more thing we can do on our left side there to simplify. So what I'm going to do when I copy this down, we still have 4 sine x, but we can recognize that our 1 minus sine x is from our Pythagorean identity, so that's going to leave us with a cosine squared x in our denominator. And then looking at our right side over here, our 4 tan x over cosine x can definitely be simplified because, again, we never really have tangents in our answers. So we're going to have 4 over 1 times sine x over cosine x, because that's our tangent, times 1 over cosine x. So that's like dividing by, because you're multiplying by the inverse. So instead of dividing by cosine x, you multiply by 1 over cosine x. And when you multiply all of those out, bring down our left side, you have 4 times sine x times 1, which is just 4 times sine x. Then you have cosine x times cosine x squared, or cosine squared x, and those two match. So that's another example of just kind of a long and grueling one. You just kind of gotta, hunger down and keep trying things until it works. And then our final problem, number 8 here. So we have cosine squared x minus sine squared x is equal to cosine x, 2 cosine x squared, 2 cosine squared x minus 1. Oh my goodness, I've been saying these terms too much in the last hour. But okay. So what we want to do initially here solving this is that we can see that we have common terms on either side that we can get rid of to kind of make this solution easier. So we have cosine squared x on both sides. So I'm just going to subtract 1 from either side. Those will cancel. I'll be left with a negative sine squared x on that side, and 1 cosine squared x on this side, minus 1. And so you can kind of recognize here with what we have now that this almost looks like it could be a Pythagorean identity, but the signs are wrong. So what I'm going to do here is multiply either side by negative 1 to change the sides. So you know that a Pythagorean identity is usually 1 minus cosine squared x. We have cosine squared x minus 1. So by multiplying by negative 1, it'll flip the signs. Over here, when we multiply by negative 1, we'll be left with sine squared x. And over here, a negative 1 times a negative 1 will be a positive 1. A negative 1 times a positive cosine squared x will be a negative cosine squared x. And we can see that with that, we've really solved our Pythagorean identity issue. So now we're left with what we would have if we subtracted a cosine over. We'd be left with 1 minus cosine squared x and a sine squared x on the other side. So we know that sine squared x, this is going to equal sine squared x, and that those two will be equal. So yeah, awesome. That's our final sheet for this section, this topic. So I hope that all makes sense. This is just something that's kind of, there's no really rhyme or reason to it. It's just all about persistence and familiarity. So the more practice problems you can do, the better off you'll be for your reassessment. So best of luck. Let me know if you have any more questions, and I'll send along pictures of all of these problems as well.